Here's an application of an NanoVNA being used with a antenna tuner to provide an impedance match for an operational system. So here is the MFJ tuner, a typical T-network tuner, where this is the variable capacitor tuning that's on the antenna side. We'll call this a C2. This is a variable inductor, which will be parallel to ground. This is a variable capacitor on the transmitter side. We'll call that C1. And the NanoVNA and our test circuit are connected. Let's look at what this represents as a schematic to help make a little bit more sense out of this. So we've seen previously that with a resistor and capacitor in series, we have an impedance, which if we do a judicious selection of the component values and the frequency, we'll have an intersection of this resistance circle and this reactance arc at this point right here. And the objective is to move this point of impedance so that it resides right at the center corresponding to a one-to-one match. This is the 50 ohm point for our system. So what this looks like for the test is these are known values that produces this point. I have a T network, which is a variable capacitor in series with another variable capacitor called the C1, C2. And then at the junction is an inductor, which goes to ground. And on the input side, I have my NanoVNA with its 50 ohm impedance. And to get maximum power transfer, I would like that everything to the right of this line looks like 50 ohms. The equations for design are well known, but rather than having to go through the details of those computations to obtain values for the capacitors and inductor to produce a 50 ohm match, we use the NanoVNA and heuristically move the point by adjusting the values of C1, C2, and L. That was also variable. When changing the reactances of these capacitors and the inductor, we're moving along arcs. It's not really easy to see on this rendition with the camera, but we have red curves and we have blue curves. And the red curves correspond to movement along arcs where the components are in series, and the blue curves correspond to movement along arcs where the components are in parallel. Capacitance reactances will move down the arc, and inductive reactances will move up. And again, this is detail, useful when doing the measurement by hand, but with the VNA, again, heuristically, I'm adjusting. First, I'll adjust the inductor value. Then I'll adjust one of the two capacitors. I'll take the capacitor C1 first. And already it's moving nicely towards the point of interest. And it's actually pretty much there. I can maybe tweak it a little bit with C2. I would go with that for a measurement value. So I've adjusted the controls on the impedance matcher, the so-called antenna tuner, and I can record those values so that if I would have these same conditions again, same frequency and same load of resistor capacitor, that I could very easily set the controls to get the one-to-one match. So in practice, with an operational system, I'll describe a little bit what my system looks like. My load is an antenna, which is an off-center fed. So I have 1/3 length, halfway, 1/3 of a half wave length in one direction, 2/3 in another direction, an OCF off-center fed. I go into a 4-to-1 balun. It's a homemade balun, and I have connectors here which let me connect this to a ladder line, actually window line. I chose that because it has very low loss. But then I go to a 1-to-1 balun to convert that to a coax connector, which is more convenient for my connection to the shack. So all of this to the right of the dash line is outside. And then inside, the first thing we see is a power meter. And then a switching network, which lets me switch radios. I have 2 radios. The one that doesn't need the impedance matching network is a KX3, which has a very good internal matching unit, automatic. But I have a 100 watt 857D, which does not have an internal match unit. And for that, I use the MFJ matching unit, the capacitor, inductor. This is connected to my radio. So for measurement purposes, instead of the radio, I connect the Nano VNA. And I set, in the stimulus portion of the menu, the from and the to frequencies, the range of frequencies of interest. So let's say I started with a 20-meter band. For CW, it's from 14 to 14.07 megahertz. I look at the dot on the Smith chart on the Nano VNA, and I adjust the controls, moving the dot to provide a match of 50 ohms, as indicated by the dot being very close to the center, to the bullseye. And then I will record the C1 and C2 numbers on the dial. The inductance are letter indicators on the dial, but I record that as well. So then if I want to come back to the 20-meter band, all I need to do is that without adding the VNA out of circuit, I have my radio here, 857D, and I just set these controls. So I've done the measurement with the VNA for each of the bands of interest, or each of the bands possible for the 857D, at least in the range that the impedance matcher will function, that is up to the 6-meter band, 50 megahertz. So set the stimulus, adjust the antenna tuner controls, provide a match as indicated by the dot on the Smith chart of the VNA, record the values, and do that for all the bands. Now my antenna is cut for 20 meters, so it is quite stable. It's pretty much a value which is not that sensitive to adjust. But on some of these other bands, especially 160 meters, I can get a match, but if I touch the capacitor control slightly, it goes off of the one-to-one match. And that's where the power meter comes in. When I'm actually operational, I set the band, I put the transmitter on low power, key the transmitter, and then look for a peak value on the output, and I tweak the capacitor values, typically ever so slightly, to optimize the output power and looking for that peak output power. So this method works very well. The traditional way of using an antenna analyzer without a VNA measurement is to put it on receive, put the radio on receive, listen to a noisy portion of the spectrum and the band of interest, and adjust the inductor first to get maximum output, maximum noise received, and then adjust capacitor C1, then C2, and then record the values. So in my opinion, this is much, much more precise and repeatable using the Nano VNA. And up to this point has been giving me very, very good results.